Hi students, welcome to the session. I am Dr.K.Varada Rajkumar, Associate Professor, Department of CSE, AML, MLR Institute of Technology, Hyderabad. In this session, we are going to learn about stack implementation using linked list. So, overview of the session. So, first we are going to see definition of stack, introduction to stacks. After that we see overview of linked list. After that we discuss about stack operations. After that we discuss how to implement stack using linked list. So after that we are going to discuss in detail about push operation, pop operation and display operation in stack. So outcome of this lecture, at the end of this lecture, you all are understand how to implement stack using linked list. So introduction to stack. So what is stack? Stack is a linear data structure that follows last in first out principle. So stack follows LEFO principle. So last in first out principle. That means last inserted element will be deleted first. So for example, this is the stack. Now, so these are the elements I store. Now, if I try to remove an element from stack, now 35 will be removed first. 35 is inserted as a last element and it is the first element is deleted. So, we call stack as a last in first out. Okay. In stack, elements are added and removed from the stack from the same end known as top. Here we are going to organize the stack using one end, that end we called as a top. The most recently added element is the first to be removed and the oldest element is the last to be removed. In this case, so 35 is recently added element. Now the first deleted element is also 35 and the oldest element is 15. So this is the last element we are going to delete. Okay. So this is about stack. In our previous classes, we discussed in detail about stack. If you want to know more about stack, refer those videos. So linked list overview. A linked list is a fundamental data structure in computer science and programming used to store and manage collections of data. It consists of a sequence of elements, each of which contains a reference to the next element in the sequence. So for example, I want to store 15, 25, 30. If I want to store these elements in array, then I am going to store like this 15, 25, 30. Let us assume A is the name, A of 0 is 15, A of 1 is 25 and A of 2 is 30. Now the same elements we organize with the help of linked list also. How? So 15, now this is the 15, now after 15 we give the reference address of 25, now this is the link. After 25 we give the reference of 30, now this is the link and end of the list we indicate with null. Okay, this is the linked list. Okay, so linked list is also linear data structure. In this data structure we organize the elements in the form of node. So each node have two parts, one is to represent data, another is to represent address of next node. Okay, if you want to know more about linked list, please refer our linked list videos. Stack operations. In stack we have three operations. One is push, another one is pop, another one is display. So what is the push operation? The push operation is used to add an element onto the top of the stack. The newly added element becomes the new top of the stack. Push means inserting a new element onto stack. Pop. The pop operation removes the top element from the stack. After the element is removed, the next element becomes the new top of the stack. Okay. Pop means deleting an element from stack. So for example, this is the stack. Now initially I am taking top. Now top equals to -1. When I try to insert a new element, for example, I want to insert a new element 10. Now I insert, let us assume this is the stack A. So A of plus top equals to 10. Now what is the top? Minus 1. Now minus 1 plus plus means it becomes A of 0 equals to 10. Now in this place 10 will be inserted. Okay, so this insertion we call as push. Let us assume this is the stack. Now what is the top value? Top equals to 2. Now if I try to delete, the last inserted element 30 will be deleted and top value become as 1 now. So top minus minus. Okay. Now this is about push and pop functions. So push function is used to insert a new element into stack and pop function is used to delete an element from stack, and display function is used to display elements in stack. Here what are the elements? 30, 20, 10. Okay. So these are the elements present in the stack now. Okay. So now we see linked list based stack implementation. So this is the implementation what we discuss here. So that is stack implementation using array. Okay, in our previous classes also we implement stack using array. So now we see how to implement stack using linked list. So to implement a stack using linked list, we need to create a data structure that combines the principles of both linked list and stacks. What are the principles of linked list and stack? The principle of linked list is elements is organized in the form of node. So one part we are going to use to store data, second part we use to represent next node address. Okay, this is the principle of single linked list. And what is the principle of stack? The principle of stack is last in first out. Okay, and all the operations we are going to perform with the help of a variable known as top. Okay, now we combine these two for implementation of stack using linked list. Node structure in linked list is data part and next part. Okay, I define this as a one structure. So this is how we define structure for a node in linked list. And what is a stack? In stack we organize everything using top here. So I take another structure. In that structure I define a variable top. Okay, here top is a pointer variable. It stores the address. So when we try to implement the stack using array, then top indicates the index of the array, but here the top indicates address. Okay, so the top is defined as a pointer variable and it is which type? Node type. So it stores the address of node. So I define this top as a data type as a node here. Okay, now create stack. So what is the initial value of top when we implement stack using array? It is -1. When we try to implement stack using linked list, the initial value of top equals to null. Okay, so this is the create stack function. So the purpose of this create stack function is this top value is initialized with null here. Okay, so that means the initially we are taking top that equals to null. Okay, so now based on this top value we are going to push the element into stack and pop the element from stack. Okay, let us see in detail about these functions. So now we see push operation. So push means inserting an element into stack. If you understand linked list concepts, then you will understand stack easily. Now in linked list we learn insert function and delete function. In insert we learn about insert at beginning. The same function here we defined as a push function. So push function. Okay, now we see. So initially we are taking top equals to null. Okay, what is the initial value of top? Top equals to null. Now I call push function and what is the data? 111. And what is the stack? The stack have one address. Okay, in that stack top is there. So that equals to null now. Now here we call the push function. So this is the data 111. Now so one new node is created. Okay, so this node have address. Let us assume address is 101 and so new node arrow data. So new node is 101, arrow data is data. What is the data here? 111. Okay, and new node arrow next means this is the next equals to stack arrow top. What is the top now? null. So in this place null, and update the top value with new node. So what is the top value now? Top value is 101 now. Okay. Now if I call one more time, push stack 222. Now what happened? The same function call, push function. Now the data is 222. A new node, one new node is created. Let us assume the address is 201. Insert the new node arrow data. So this is the part, new node is 201. 201 arrow data is data, that is 222. A new node arrow next equals to stack arrow top. Now in this place you store the top value, that is 101. That's it. And update the top. So now top is 201. Okay. So now what is the top value? 201. After 201 we traverse to 101. Okay. So let us assume I try to insert new element 333. Okay. So this is the 333. Let us assume the address is 401. Now 333 is inserted here. So new arrow next equals to stack arrow top, that is 201, and update the top, that equals to 401. Now top equals to 401 now. If I try to insert one more element 444, so now another node is created. Let us assume the address is 501, and new node arrow next equals to stack arrow top, that is 401, and update top, so it is 50. That's it. Okay. Now this is the list. What is the top value? The top value is 501. Okay. So always top indicates last inserted number. Here the last inserted number is 444. Top indicates 444. Okay. So this is how we are going to insert a new element in stack using linked list. Now we see pop function. So pop function we use to delete an element from stack, that is a pop an element from stack. Now if it is a stack, the last inserted number is 444. Now if I call the pop function, then the deleted element will be 54 and update the top with the next value. Now we see how it is executed. Now I call top stack. Now we create one temporary variable temp equals to stack arrow top. Now what is the top value? So 501, and stack arrow top equals to temp arrow next. What is the temp? 501. So 501 arrow next is 401. So now top is updated with 401. Here I am taking one variable data. So data equals to temp arrow data. What is the temp? 501. 501 arrow data is 444. So after that I delete this by using free function. So free temp. So return data. What is the data? 444. Now it display popped item 444 as output. Okay. So this is how we are going to pop the element. If I call one more time pop, now 333 will be deleted and top is updated with 201. Okay. So now 333 will return to this called function. Okay. So this is how we are going to delete an element from stack. It is similar to delete at beginning in linked list. So now we see display function. The display operation means the purpose is display the elements of the stack. Okay. Here I call display stack. So let us assume this is the stack. Now we call the display function. So this is the display function. Here I am taking one current variable. So temporary variable. Current equals to top. What is the top value? 501 now. Now current not equals to null. Here what is the current? 501 not equals to null. Yes, it is true. So enter into this block and print the current arrow data. What is the current? 501 arrow data, that is 444. Okay, 444. So after that update current with current arrow next. Now 501 arrow next is 401. Now current equals to 401. So again you check the condition. So 401 not equals to null. Yes, it is true. So print the current arrow data, that is 333. And update the current with current arrow next. Now current becomes 401 arrow next is 201. Again check the condition 201 not equals to null. Yes, it is true. So print the data in 201, it is 222. So next update the current 201, arrow next is 101. 101 not equals to null, it is true. So again print the data in 101, that is 111. So next update current with 101 arrow next, that is null here. So null not equals to null is false. So now we terminate the loop, okay, and print null here. That's it. So this is the output. So 444, 333, 322, 311 null. Okay. So this is how we are going to display elements in stack using linked list. Summary of the session. In this session we learn 3 functions. One is push function, pop function and display. So push function is used to insert an element into stack. So pop means deleting an element from stack. Display function is used to display all the elements present in the stack. In next class we are going to see how to implement stack using linked list in C programming. If you have any doubts, place your doubts in the comment section. Thank you.